Good morning and hello, everyone. Welcome to the second day of the DSC MENA 2024 hybrid conference. I hope you had a fruitful day yesterday. I'm Holger and I will be here as a tech support during the tutorial. And I want to introduce you to our tutor, our first tutor today. It's Mr. Israel Diago. He is an AI engineer and data coach at Join Monument, and he will hold a library demonstration under the title Navigating the World of NLP and Text Analysis. Enjoy it.
Great. Thank you so very much for the intro. Hi, everyone. My name is Israel Odeajo from Nigeria, and I'm so excited to be taking this very section. So I also believe that the material for the section has been shared, and we can all go through it even as we start this section. So I believe that everyone can hear me, and it's excited to have everyone on this call. So today we're going to be talking about NLP, and like we know that NLP stands for natural language processing. So what are we going to be doing the next 2 hours is that we're going to start from like basic things that you should know about NLP. Then we graduate to the part whereby we can then, do some pre-processing around natural language processing. Then we can do a whole lot. Okay, great. So we can do a whole lot, in the same process. All right. So like I mentioned, my name is Israel Diajo from Nigeria. Then you might want to connect with me on my LinkedIn at Odeajo/Israel, on Twitter at Israel Kings1. So then we move to work, and I'm using the Google Code Lab environment in case you also want to try some of the code we want to run in this section. So what we are doing is in 3 phases. There are about 3 different notebooks that we're going to be working with. The first one is the starter, whereby we're going to learn about the basics around NLP, why NLP is important, and of course, we look at some of the solutions around time that focuses on the usage of NLP, and we will be able to do some of this pre-processing. So the some of the prerequisites for this section is that you have a bit knowledge about writing Python programs. Also, we want to believe that at a point you've been doing some amazing work with building machine learning models. Even if you've not, NLP is one of the places that you want to do if you have so much passion for building stuffs in the AI space. So it's more of an advanced machine learning thing, and of course it also belongs to the deep learning world as we have it. So NLP, like we say, stands for natural language processing. So it is a branch of artificial intelligence that gives machine the ability to understand and process human languages. So what you should have in mind whenever we are doing NLP is the possibility of understanding and processing human languages, right? So, and of course, human languages can always be, most time for natural language processing, can either be for text or say audio. So most of the data we are going to be working with, most of the time, we focus more on text or audio, right? These are like the 2, main kind of data we're going to work with. But for this tutorial, we're going to do a lot around textual data. For many of us who have background in building machine learning model, for instance, you possibly have at one point or the other, have tried, building machine learning model with what we call tabular data, that is, that has columns, and records. But for this, it's a textual data. So that this is a combination of several texts into just one column, right? So that's, what we are trying to achieve at this end. All right, so that's like one of the things we're trying to achieve at this end. So some of the history of NLP is that NLP has been started as far back 1950 when Alan Maxine Turing published an article titled Computing Machinery and Intelligence. So the foundation work is based on artificial intelligence and discusses the automatic interpretation and generation of natural language. As technology has evolved, different approaches have emerged to deal with NLP tasks. So you want to also understand some of the application of NLP And of course, some of these includes text and speech processing. So for example, our normal or known voice assistants, say Alexa or Siri, or several ones who can also have been made in our local dialects or local languages. Also, we have text classification, like our Grammarly and Microsoft Word, our Google document is an example in that respect. Also, we have information extraction, like the picture of our search engine, like our DuckDuckGo and Google, for example. You do your search and you write some text and get some result. Okay, some example also cut across our chatbots and question answering systems, like our website bot, like say our chat dialog flow, like the Google dialog flow, our chatbot solution. Also, we have our language translator, like our Google Translate, or say our text summarization. These are pictures of the possible solutions that you might want to build or that you might be working with, at your end. So how do we use regular expression in Python? So one of the key things we're going to start with, because if you're going to work with natural language processing textual data, one of the key things you must be able to do as a Python programmer or as an NLP expert is that you must understand the regular expressions that might exist in your data. So these expressions, they are really not very much useful in the real data, but of course this might be some of the omission. This might be some of the issues that we have, with our data. And these are some of the things you want to try as much as possible to undo in that process. So at this point, it's going to be a bit basic, just trying to look at how we can use some of this pre-processing in our NLP data. All right, that's what we're trying to do. All right, great. So how do we use regular expression is like the first thing we're trying to learn. So for us to use regular expression, generally known as regex, and in Python, we first need to import a module called reg. All right, RA, regular expression. So let's look at this example. So we say import reg. All right, this is a picture that we want to work with regular expression. And of course, we have a variable s where we save some textual data here, where we have gig for gigs, a computer okay, so gig for gig, a computer science portal for gigs. So this is the text that we have. So we are using another variable called match, and here we are using a regular expression, and inside this regular expression, we are using a search, which is like a method there. And what is this search doing? You're trying to search for a particular text called portal from our S, which is like the string that we have. So what you really want to know is that if I go through this string, I want to primarily understand this portal, what index do we have it? Which this portal, what index do we have it? So we are doing match.search. All right, here we are searching the match.start. So where does this index start for? What position is this? And where did it end? So if we run this code, we're going to have two results. The start index, which shows where this portal is at index 34, and the end here is at index 40. Just trying to show you some pictures around regular expression. Okay, so we have the meta characters, because this meta character is some of the special characters that you're going to be using. And of course, they have their own meaning in regular expression. They also play a crucial role in crafting a pattern where you can use to make a match, make a search, or manipulating your string data. And of course, below here, I have several, meta character that you can use whenever you're working on regular expression function in your task. So some of the meta character cut across the backslash, the list sign, the hyphen, the dollar sign, the asterisk, the string, this question mark, asterisk, the plus, the brackets, curly braces, the tuple sign. All of these are several meanings, in working with regular expression. But at this end, we possibly will not be able to explore all of them, but we're just going to look at some examples and see where we can use them. So why is regular expression important? Because it helps you as someone working with a textual data, an NLP expert that you are, to be able to pick up, a number of special character within your text data, and you can decide to format them. All right, so that's what regular expression helps us to achieve, and there are several ways of using them. That won't permit us to pay more attention to each of these meta characters, but you can always look through the material afterwards, or possibly, all right, good. So, or possibly check out, about regular expression in some of the attached materials below. So, understanding and utilizing these meta characters are fundamental to effectively using regular expression for pattern matching and text manipulation. So, these are, basically how you can use it. So, it all depends on what kind of data do I have, what kind of tasks do I want to carry out. And that's like one key thing that we're trying to learn here. Also, if you have data that is textual, one of the things you also want to do is what we call tokenization. All right. So tokenization in NLP is one of the foundational techniques that involves dividing a sentence or a phrase into a smaller unit, and we call that tokens. So one of the things you want to achieve whenever you are working textual data is that you want to tokenize that data, such that if it is in sentence, which is like a couples or a combination of many couple, all right, which is corpora, all right, at that point, what you're trying to do as an NLP engineer or as an NLP expert is that you're trying as much as possible to convert that, combination of several words into a sentence, or you want to convert it into a token, all right, which is just a word. So that's one of the things you want to try to achieve. So what, of course, the token can include words, can include dates, can include a punctuation mark, or even fragments of words. So in this material, we're trying to understand some basics of tokenization, its types, and its use cases. So like I've mentioned, in NLP, we use tokenization for processing or breaking down of text into smaller units, or you say into tokens, all right? So these tokens are typically words or sub-words in natural language processing. It is a critical step in many NLP tasks. This could include in our text processing, language modeling, or say machine learning translation. Tokens serve as the building block for further processing or analysis, enabling the conversion of your unstructured data into a structured form suitable for your machine learning algorithm that you tend to do, especially when you're doing text classification. So types of tokenization, tokenization can be classified into several types based on their text implementation methods. One of them is word tokenization. So what does that describe to us? It divides text into individual words. So for example, if the input text is tokenization is an important NLP task. So when you output a word tokenization, the output you get is tokenization is an important NLP task. All right, that's a picture of what word tokenization does for us. If it's a sentence tokenization, for example, if the input is tokenization is an important NLP task, it helps break down text into smaller units. Tokenization is an important NLP task. It helps break down text into smaller units. So if you are doing sentence tokenization, it's going to break this guy into tokenization is an important NLP task. That's the sentence one. It helps to break down text into smaller units. That is sentence two. So this is a picture of how we use sentence tokenization. Another example could be subword tokenization, which breaks down word into smaller units. So an example which can be an input could be tokenization. So it breaks down tokenization into subwords. So the output will now be token and ization. All right, token and ization. Okay, so the next thing you can have is a picture of a character tokenization. So for character tokenization, just like the word says, characters. So it divides the text that you have, those combination of words, into individual characters. So an example can also be an input of tokenization as the text. So the output is going to be having all of these as singular characters: Tokenization. Tokenization. All right, so that's like a picture that you have whenever you are working with character tokenization. So why is this important? Some of the reasons why this is important is effective text preprocessing. It is simplifying a raw data for easier processing and analysis. We talk about feature extraction, hereby you can enable numeric feature of a text data from a machine learning model. Of course, it's also needed for language modeling. So this facilitates organizing representation of your text for text generation or language modeling. Also, this is important for information retrieval, which is essential for effective indexing or search based on a particular word or phrases. Also, we have text analysis, which support NLP tasks like sentiment analysis or what we call NER, which is name entity recognition. These are possible tasks you want to carry out, using NLP. Vocabulary management. This helps to manage a corpus of vocabulary by generating a list of distinct tokens. Also, we talk about text-specific adaptation, which can be customized to suit specific NLP tasks such as summarization or, say, machine translation. Of course, it's also needed, tokenization is needed for pre-processing steps. It transform raw text into a format suitable for further statistical and computational analysis. So let's move forward to learning how we can then tokenize our text using NLTK. So NLTK stands for Natural Language Toolkit. So this is one of the libraries that we use whenever you want to do any NLP tasks in Python. Of course, we have several other libraries we can work with. We have Spacey, we have TextBomb, we have a number of them, but one of the most used or famous, widely used libraries that you want to use whenever you are doing NLP, task is NLTK, which is Natural Language Toolkit, which I'm going to use a number of that, even for some of the projects we're going to do on this call. All right, so tokenizing text using NLTK in Python. So we are saying to utilize NLTK, which is Natural Language Toolkit for text tokenization. The first thing you need to do is to install this NLTK on your system, or say on a cloud platform like the Google Collaboratory platform that I am working with. All right, so that's like the first thing to do. And of course, we are working locally. Say, for example, you are using an Anaconda Navigator. You can install this in your environment on your Anaconda Navigator. And one easier way is to use your Anaconda prompt, to install this. And of course, it is going to be installed into the root, environment where you're working. But because we're working, for me, I'm going to be doing a lot of this tutorial around this Google Collaboratory platform, which is like a cloud platform where we can just run our code within a cell and we are fine. So the first thing to do is to install this library called NLTK if it is not installed. So what you need to do is to say pip install NLTK. That is the name of this package we're trying to install. All right. So the directory we have here is a picture in case you're just trying to install it, on your system terminal, but we're not doing that here. So that's what we have here. So we are trying to import it after we have successfully installed it. So when we want to install, we're going to do, and because we are working here, we're just going to do something like this at your level, pip install NLTK. All right, so if I run this, of course, it might tell me that it's already successful because I've already used it and I've possibly have installed this in my working environment. So this is coming up here. So the next thing I want to try out is to then import the NLTK. All right. Now there's several modules inside this NLTK, and there are a number of them we will also going to be working with in this tutorial. So inside this NLTK, we have a number of modules or packages that we also need to download. We have the NLTK already, but we have several modules around it that we want to work with. One of them is the Pocket, which is also necessary for tokenization whenever we are using NLTK. So you can see that it told me that the package Pocket is already up to date. So that means this is like already installed in the environment I'm working with, which is I'm fine with that. Never want to use that. So Pocket is a package in our NLTK toolkit, which is a set of libraries or programs for symbolic and statistical natural language. So this Pocket here is used for dividing a text into a list of sentences by using an unsupervised algorithm to build a model, all right, for abbreviation words, collocation, or word that starts a sentence. So we can also use this for sentence tokenization, which means that we can split a text into sentences. This also is particularly useful for application that involves NLP tasks like text summarization, sentiment analysis, and so on, where understanding the boundary of sentence is important. So to use this guy, we need to say from NLTK.tokenize, we are importing sent tokenize and word tokenize. I mean, from the narration I've done, explanation I've done so far, set tokenize simply means that I want to convert a text to a sentence. Word tokenize simply means I want to convert a text to a word, which is also known as token. So I want to be sure that we're on the same page. Guys, can you just put a yes on the chat if we're on the same page? I want to be sure we are all on the same page. I've not lost anyone in the process. Can we just use the chat? Just let me know that you're there, possibly with me to the stage we are right now. Can we just use the chat? Maybe a yes or something. Just going to give me a picture. Oh, great. Thanks, Miriam. We are with you. Yes, I'm following. Thank you. Amazing. Thank you guys for that. So we just pick it up from there. So the first thing we're trying to do is to import the module we're working with. Okay, thank you. Yes, I'm following. Oh, great. Thank you so much. All right, so from NLTK to tokenize, you want to import sentence token and of course word, token, just trying to, check through what you have here. All right, so now we're trying to check this on an example. All right, so we want the text. So the assumption that we're working with a text data that has natural language processing is an exciting area, which budget has been allocated to this. So this is like the text that we have, that we are working with. So the next thing I'm trying to do is that this sentence that I have, I'm using the sentence tokenized text, to tokenize the text that I have, so that I can have this when I'm using sentence tokenized. I want to have these two guys, right? I want to have them as a sentence. They are just text. I want to add them as a sentence. So if I run this now, you can see that now. So this command shows that this is sentence 1 and this is sentence 2. So let me ask, so this text now has converted, this text has been converted to how many sentences now? You can use the chat to let me know that. So this has been converted to how many sentences? How many sentences we now have after we have used our tokenize now? How many sentences do we have? You can just use the chat to give me a feedback. How many sentences do we have now? Now using our sentence tokenize module in our NLTK. So how many sentences do we have? So how many sentences do we have now? If anybody wants to drop a comment? Okay, great. So what we have here now is that we've tokenized and we now have 2 sentences. Now we have natural language processing is exciting area. That's one. The second one is not which budget has been allocated for this. All right. Which budget has been allocated for this. So the next one is that we want to use a module called word tokenize. So here, what are we trying to get is that instead of getting sentences, we want to get word. So if we use this method now called word tokenize, the result we get shows that we now have every of the guys that we have in our sentence now as a token. You can now see we now have natural language processing is an exciting area dot huge budget has been allocated for this. So if you look at this carefully, we have 2 methods. We have the sentence tokenize and we have the word tokenize. All right. So this the approach that we've used here. Now, moving forward, we're just trying to use a more complex data because, this is a picture of what the data is going to look like. So we have several combinations of sentences whereby we are now also using sentence tokenize and word tokenize. So I'm running this now. So if we have this now, of course, if you begin to scroll, you will see all of these working now. So what we have here is that we have used the sentence tokenize, the word tokenize. All right. So I want to be sure that we understand this. Maybe on the chat, you might just want to tell me you got that. That will help me to know if we get a picture of using sentence tokenize and word tokenize. Okay, so we're still trying to tokenize, and we are using another library in our NLP called TextBob. So what TextBob helps us to also achieve is that it helps us to perform tasks like text tokenization, whereby we can also, install it and its dependencies, following these steps to install TextBob, and of course, downloading the NLTK Corpora. So the NLTK Corpora is also more like a module that we're using at this end. So if we do not have TextBob installed already, we just want to say pip install universal TextBob, which is like the library we also want to use to undo, our tokenization. All right. So after this has been successfully installed, we need to import it. So we say from TextBob import TextBob. All right. So you might want to take note of the cases. from text bulb import text bulb. Of course, we still have this text. So what we did here was that we created a text bulb object. So bulb object, we are assigning this particular variable, which is now an object now, text bulb that we have imported here. We are converting that on the text. Then from this module, we want to get the word tokenized, we use a method called words. To get the sentence case, for Bob object, we use the method called sentences. All right. We're trying to achieve the same thing, but we're using different methods. Okay, so if we do word tokenize, for word tokenize, you can see we have this. For sentence tokenized, we have natural language processing is a feat of computer science. So what we are doing basically here is that for text bulb, we are using the words methods to get the word tokenized. For sentences, we are using the sentence method to get all our sentence tokenized. All right. So another thing you want to work with, especially at any time you are working on tokenization, after doing tokenization, is going to be your. So I'm just going to put something here, a word we're live, the NLP section at DSC MENA. So this is our word here. So another thing you want to do is what we call stemming. So what is stemming? Stemming is an approach that we use whenever we want to get more like a root word of a particular word. For example, in normal English, we have the word running. So running, for example, the root word of running will be run. So that's a picture of what we're trying to achieve with stemming. And of course, we have two very common stemming approach that we can use. One of them is Porter stemmer and lemmatization. So we do stemming and lemmatization for the whenever we want to, get the root word for whichever task that we are doing. So why we're learning all of this is because they're like the approaches that we use whenever we want to, work on textual data. All right. So the one we're having here is that we are live at NLP section at DSC MENA. Right. So one of the methods we're going to be using is Porter stemmer, which is gotten from stem.porter. All right. Stem.porter. So if we run this, the next thing we want to get is that for every of these words here, we want it to, find the root word. All right. We want to reduce every word to stem. All right. Every word to stem. Like I gave example the other time, running will be reduced to run. All right. Fighting, if you pass it to a stem, all right, it's going to be reduced to its English word, its root word, fight and all of that. So that's like a picture, that you have most of the time. So we are reducing this word. So we are using the post stemmer method, all right, which by using the dot stem on all the words that are available in our word. So here we are looping through. So here now we are using an example of what we call a list comprehension. All right. So for word in words, so for every word you can find, it brings them into the stem. Whereby, so if we print the stem, now we have every word, in its root form, right? And that's what we're really much trying to achieve here. Also, if we use the lemmatization, so the lemmatization approach is, much better because it gives us root words that, we can actually trace, say, in the dictionary and all of that. So that's, a picture that we have here. So the first thing we do whenever I want to use lemmatization is that we also have to download a particular module called WordNet. So the WordNet helps us, as much as we can to get the root form of every word. So the WordNet has been trained on, a numbers of, languages. It has about 200 languages that it has been trained on. And this WordNet has the capacity, to give us the root word of all of these words. But the difference between stemming and lemmatization is that lemmatization is going to give us root words that can actually be found, say, in a dictionary that you can trace to a vocabulary. All right. So we can just change that here. Let's have another word here. So let's say we have our words here and we have these guys. So we have fighting. We have our conferences. Eating. Okay, so let's say these are the words. So here I'm trying to download the WordNet, which is necessary whenever we're doing implementation. So the same approach, just that here we're importing the WordNet lematizer here, and the WordNet lematizer is using the module called lematize to perform this function on the task. Okay, so you can see this now. So the root word that we have here for them, fighting conferences, is seen as conference. I mean, this is the word that it has been trained on. These are words that it understands in the background. Okay, so this is the approach of reducing every word in your text to a particular module. Okay, so lemmatization is also another pattern for reducing your word to its root form. Now, lemmatization and stemming is the same thing, but for stemming, most times stemming might not give you an accurate word. All right, it might give you a word that does not even have any root word in the dictionary or does not have any use case. For example, it might make conference, so it might make conference conference, or a word that does not really have meaning. But lemmatization is an approach of getting the root word of a particular token, all right, of getting the root of a particular token, but the root word you are getting, we find its root in the dictionary. So it is like a word that is available in a vocabulary, and that's why we're downloading WordNet. So WordNet has combination of several words that has been trained, on, and it understands at this point, right? That's what lemmatization is. I hope that is clear on lemmatization, Yusuf. Okay, so that is what lemmatization does. It gets a word, all right, the word is already tokenized. All right, great to hear that together. So the word is already tokenized, so it picks every of these words that you have, all right, and gives you a root word for it. But of course, these words are generated from the WordNet, library, and the WordNet is like a module that have several, words that are installed on it. So another thing, or another pre-processing that you want to do. Okay, so what is the difference between stemming and rooting? Yeah, I think the differences between them is going to be the word that you get. So for stemming, like I mentioned earlier, so stemming is going to give you, words that it thinks that has been trained with. But most of the time, rooting, we just give you a picture of the base words of that token. So that's like the difference between these two guys. All right, so the next pre-processing we want to work on is stopwords. And of course, what are stopwords? Stopwords are English words, or say any language word, that are available in your textual data, but they are not useful for anything really. But for the sake of making that sentence meaningful, whenever we are having this, whenever we're getting the data, these stopwords are available there. These stopwords are useful at those points. So, and of course, one of your pre-processing is definitely going to be that you want to try as much as possible to remove your stopwords. And of course, the same way the approach we'll be using is that some of these modules, we need to like download them within what we have. So in our stopword, for example, we have like, say about 200 languages that are available in our stopword. Of course, for many of the tasks we're going to be doing now, it's going to be English because our text data is English word. But say, for example, if you are working on a data yourself and the data is in another language, so if you want to remove stopword, you have to remove stopword for that particular language. But most of the data we are working with at the moment are going to focus more on English. So the next thing I'm doing here is to download the stopwords. So from NLTK couples, I'm importing stopwords. And of course, after getting this stopword, I still want to like get, a word tokenized. So the texture data we are working with is example sentence, which is, this is a sample sentence showing off the stopword filtration. So the next thing we did was that we set our stopwords for a particular language. I've told you the stopword can belong to different languages, say English, French, Chinese, several languages are available there. So we're setting this to be English. So from word token, so we are tokenizing our words to words, all right, in our sentences. So we have all of these words in a sentence. And the next thing we are doing here is that we are converting all our words, if they are not in lowercase. And of course, because all of our stopwords, most of them are in lower cases. So that's why we're trying to check that they are not in the stopword. So anyone that is not in the stopword is going to be added into our filter sentence, because there are several words there. The picture we're doing here is that we are looping. So for W, which is our creator in word tokens, so we are, and if that word is not in in stopwords, then append this to our empty list here. So here I want to print all the word tokens that I've tokenized. Then also I want to see all the filter sentence. So the filter sentence here means that I've removed stop words from them. So this is a sample sentence, comma, showing off the stop word filtration full stop. So this is a picture of what the exact word looks like after we have tokenized it as what, tokens. Then the second part is showing, the stop, the words that the stop word has been removed. So we are left with this sample sentence showing stop word filtration. So it has removed all the stop words that are available in these tokenized sentences. Okay, so here again, we're also trying to use another, like I told you, we have several modules or several libraries that we can, work with whenever we're doing NLP. All right, apart from the MLTK that we work with, the text bob we work with, we also have another module called Spacey, right? And of course, Spacey is a library that comes under NLP, all right? It's an object-oriented library that is used to deal with preprocessing of text, sentences, and of course, to extract information from the text using the module and the functions. Tokenization is the process of splitting a text or sentence into a segment which is called token. This is the first step of your text preprocessing, and it is used as input for subsequent process, is like your text classification, your lemmatization. Now, in natural language processing, stop words, like we mentioned, are frequently filtered out to enhance text analysis efficiency. Elementary stop words can improve the accuracy and relevance of NLP tasks by drawing attention to the most important words or content words. Of course, the aim of this tutorial is to explore stop words. So now from our sparsity, we are loading the module called English Core Website Stop Words, all right? That is, this module asks us to load Spacey English module. So that is a pass, and whenever text we pass in there is able to, give us the word by removing the stop word that we have there. So the text is, this is a pen on the table. There is a pen on the table. That's the text that we're working with. And of course, now Spacey, we are loading the English module of our Spacey. Then here we process the text using the Spacey module that was stored in NLP of text. So from here, we're also removing the stop words, token.text, that is, we're tokenizing it too. Then we are adding all the remaining words into our clean text data. Also, we are printing the original words, and also we are printing the text after the stop word has been removed. So that is what we have here. So the original word is that there is a pen on the table. So after we have removed, we have tokenized this, and after we have removed the stop word, we have left with pen and table. This is just a picture to show how we can use this module for text, stop words. Another, another module that we can use in our NLP is JEXIM. And of course, we are using this JEXIM to remove, stop words. So what we have here is that from JEXIM.pacing.preprocessing, we are importing remove stop words. So another sample text is the majestic mountain provide a breathtaking view. So remove stop word using JEXIM. So we're using the module called remove stop word, and we're removing it on the text, next text. So the original word is the new text. And of course, the one after we have removed the stop word is new filter text word. So here we can see the results. At some point, some stop word has been removed. A has been removed here, and we still have, these guys. So if you're on the same page on stop word, can you just put a yes on the chat just to be sure that we get that? So here we have used like 3 different, approaches to remove, our stop word. Okay, is there a difference in time between those techniques? So not really. It depends on you as the person, working on the task and the approach you are much familiar with. A number of us, we use more Pocket most time to even do some of these things. So people pay attention to using, some libraries than themselves. Some people use TextBob. So it's all about you as a person, what approach do you find comfortable to leverage on whenever you are doing your preprocessing. So there is no really when and when to use them. You just like, it's more like you as a person, the approach you think that works much for you. Some people, use JEXIM. Some people are used to using NLTK. For me, most of my tasks, I do a lot around NLTK than even most of the modules we're talking about now. So it's about you as a person. Which one works well with Arabic language based on your experience? Really, I've not worked on any data that focuses on that. So I think that one thing you want to do at that point is like to check them out and see. Of course, because the time of processing also is something you can also want, like look at. But I mean, just try it out and see the one that is able to like pre-process your data, as quick, as possible. So I mean, time is also a factor when we are doing our pre-processing. So when you check them out, you might possibly be able to identify the one that works well. So because most of my tasks that I've worked with are more like English task. So so I think that should possibly help. So thanks for asking. Okay, so another approach or another information you might want to get whenever you are working with your textual data is part of speech tagging using text bob. And of course, here you just want to identify what part of speech does this module or does this text, is it a noun, is it an adjective, just want to identify where and when it belongs to. Okay, so text bob module is used for building programs for text analysis. One of the most powerful aspects of text bob module is part of speech tag, so it's able to tag it as part of speech. And of course, if you read about all of this part of speech, across several platforms, you're going to see what each means. Noun, JJ, they have them explained. But for you to be able to use this part of speech tagging module, you have to download a module from an NLP called Average Perceptron Tagger. So this is a module that helps us to like tag our text. And of course, the text is still there. And of course, we're using text bob, which we have converted to a text bob. Then the next thing we have here is that we're using the POS tag pattern to get, so it picks every word that you have and it tells you the part of which it belongs to. So the Sukanyam belongs to the noun. So all of these has meaning on their own. So when you check through the part of speech article, you're able to see the full meaning of each of these words. But the key thing we're taking note here is that we're able to know which part of speech does each of these guys belong to. Okay, so some little also cleaning that we might want to do on our data is that we have this string that says Python 3.0 released in 2008 was a major revision of the language that is not completely backward compatible and all of that. Yeah. So yeah, if we print this string of text, we have this. One thing I also did there was, okay, let's say we want to convert this to lowercase, everything there. Especially even whenever you're working with textual data, one of the things you want to try to do really is to like convert all of the guys, to lowercase, because anything you want to do, it's easier for you to leverage on every of the data being in the particular case than having them in several cases. So what I did there was to convert them to lowercase. So I have all of them in lowercase. So I don't have issue of character, sentence case issues, capitalized cases, I don't have those issues again. Another thing I want to do is that I'm using regular expression here to remove every decimal digits, that I have, looping through all of them. Like I said, we talk about meta characters when we are starting. We might not be able to talk about all of them here unless when we are using them. So there are several of these meta characters that serve several purposes. But for the one I'm using here is that I want to substitute whenever I have a digit, everywhere I have the that plus is there with an empty space, right? So that is what is happening here. You can see here that it has removed everywhere I have, numbers in my stacks. It has removed them. So the next thing I'm doing here is that I'm substituting everywhere I have all punctuation except the word and the space. Any punctuation should be removed. All right, that's what I did here. So why finally here I tried to strip off. Sorry, is that a comment for me? Okay, I guess I will just continue. Thank you. Okay, so from the stripping off here, so what I'm stripping off is all this empty space I have before my Python and all. So if I run this guy, you can see now, so it has removed all the space for me over there. Then the next thing I'm doing here is that I'm trying to convert all of them to like a one-on-one of their them by splitting them. So when I split this, I want to get each of them as a word on their own. So the last thing I did there was that I decided to also remove stop words in all the words that we have. So why do we have to remove stop words? Like we said, when you're having a sentence, you have stop word to make the sentence make sense. But in the case whereby you don't want that sentence or you want to do so much other thing with your data, you want to like pre-process it, and that's exactly what we are doing here. All right, so another concept we want to learn here is what we call bag of words. So what is bag of words? Here you want to try as much as possible to like understand for every word that exists in this text, right? How many times does this word is available in this sentence? So this is more like trying to do like a frequency count. Okay, oh, so we have a number of words here. So I'm doing a lot of stuff on it. The first thing I'm doing here is that I'm using the sentence tokenize on the text. Then from I in range of the length of whatever is in the data, I want to make sure that every of the sentences are in lowercase. I want to remove any white space there. I want to also remove any, so I'm trying to remove, some stuff from the result that I have. So if I have this now, so every word I have now in my word to count now, I want to pick every word and I want to count it. So that is more like a dictionary picture. That's why I'm having an empty dictionary here, which is a picture of keys and values. So for every word after it has been tokenized into sentences, after I've have them individually, then pick every of these words. That's what this looping is doing. Pick every of these words, look, convert it to a lowercase. So now for every word here now, I'm converting to what tokenized, that is no longer sentence tokenized. Pick every word here and what tokenize it for me. For every word I can find here, and if it's not in the word before, that's a one. Because if that word has existed before, add another one to it. But of course, this action is going to happen as many times as many words can be found because we are looping through it. So if we run this now, we're going to have a result. So let's check our word counts and see the value that we have there. Okay, so this gives us a picture of every word that we have. So of course it's a lot of words because so I want to start. So you can see beans has 2, I is 12. So you have several words that has been counted, here. Okay, great. So scrolling to the next cell. Okay, so another method you might want to also use whenever you want to do this approach of your word count is using what we TF IDF. TF talks about term frequency and IDF talks about inverse document frequency. So what we're still trying to do at the end of the day is that we're combining several, because your data can be in several formats, or of course your data can be very voluminous, and that's exactly what your TF IDF vectorizer helps us to achieve. So we combine. So the assumption is that we have several documents. We have several, data here. So DO is gig for gigs. D1 is gigs. D2 is R2G. So what we did here was to combine these guys together, giving you a picture of a corporal, which is a combination of couples together. So we have this text together now. So we didn't want to just have the values here, and that's exactly what our TF vectorizer is going to do. It calculates the value for not just counting in, it calculates that value, so that it's more like it's doing a calculation, in the background for us. And of course, we transform this. We're using the TF vectorizer. We transform it on the string for the gigs for gigs. So every time we're saying gigs appears like 3 times, in the data that we have. Then it's getting, it's transforming this guy for us. Okay, so you say this has not been defined. So I guess that we did not run the code from this part. So, some of these codes depend on themselves. Sorry, I didn't hear that.
Okay.
Sorry, that's a bit of background noise. I want to be sure. IT support stream 3, okay, great. Thank you so much. Okay, so if we run this again now, I think we should be fine now. Okay, great. So this has been fixed. So if we check the result now, we're getting the IDF values. So the element 1 and the element 2. The element 1 is using the fixture name get out, because we have already converted this guy to a sparse matrix now. So we cannot really say what the values are again. So what we are doing here is that we're using the get feature name out to get the name of the feature, and the IDF underscore is giving us the element 2, which is like the value that we have. So for 4, it does the calculation. We have like 1.69 as the value, after it has been after it has been concatenated. Gigs, which appears more time, it does the calculation. We have 1.28. R2G has about 169. The number of times these guys, exist in what we have. We can also decide to get the, the index. We can also decide to get the IDF values for each of them. So 0, 0. So what is the value of 0? That's 4. For 4, 4. you're going to get a value of when it is 0 and the value is also 0, we have 0.54. When it's 0 and 1, it is just trying to compare, values to themselves. We have git as 1, 4 as 0, RUJ as 2. And of course, we can also compute the metrics of each of these guys. So finally, in this tutorial, before we check a real life, like problem, one of the tasks you might also want to do is, sentiment analysis. So what's sentiment analysis? Sentiment analysis is an approach that helps you to classify a particular text to either be positive, to either be negative, or say to either be neutral. All right. So a module that we can use to achieve that in our NLTK is going to be VADA_lexicon. So this is a module that we can actually use to achieve, having this kind of results. So I mean, to download that, of course, some of the guys above are downloaded before, but just want to be sure that everything is working fine. So we have these tweets. So we have like 3, result of tweets. So the first one is, dear at Vexing Support, your service is straight in Dallas, been with you all over a decade, and this is all time low for you all. I'm taking no internet at all. The second tweet is, I veteran support, I send you a DM. The last one is, thanks to Mitchell and all at veteran support who helped push my no-show phone problem along. Order cancel successful, and I've ordered this for pickup today at the Apple store in more. So these are the tweets we're going to have this guy. So what are we trying to achieve on this task? What we're trying to achieve is that at the end of the day, we want to be able to say that tweet 1 is a positive one, or a negative one, or a neutral one. All right. That's primarily, what we're trying like achieve. All right. That's what we're trying to achieve. So we are saying for tweet in tweets, we are using our text bob, which is like another module that we have here on these tweets. Then from this module, we are using from the text bob module, we are using the sentiment to get our results. And of course, for the first result, we say that the polarity of the first for the first tweet is 0.1 and the subjectivity is 0.35. The polarity is the one that really talks more about whether it is neutral, it is positive, or it is negative. Subjectivity more talks about the score that is having, more like the compound score picture, right, that we have. So most of the time we want to pay more attention to the polarity, all right, that we have here. Now let's look at another approach of doing this, is that from nltk.sentiment, we're using a module called Sentiment Intensity Analyzer. And of course, Sentiment Intensity Analyzer, I decided to make it an object here. So for tweets, from Sentiment Intensity Analyzer, I'm using the polarity scores here, and I'm printing the score. So look at what we have here. So then if you look at, so for the first text, it picks that and say that the text shows about 13% negative, neutral shows about 72%, positive shows about 14%. So the compound is a combination of your negative, neutral, and positive. The combination of your negative, neutral, and positive. So the compound score shows about 0.05. So can I assume that this kind of tweets shows more of a negative, because you have to be able to conclude on the results. The second tweet has a negative of 0.0. The neutral about 1.0, which is about 100%. The positive, which is about 0.0. And of course, compound shows 0.0 again. So that means like this shows more that this is a neutral result. And the final tweet shows a negative of 0.075, neutral of 0.754, and positive of 0.17, which is about 17%. The compound score shows about 53%, which shows more that that tweet is more of a positive tweet than others. But of course, it gives you the percentage of what the polarity score of each of them are: negative, neutral, positive, and compound. So this is some of the tasks you might want to carry out on natural language preprocessing. Yeah, so shortly we're going to be going through a real life problem using some of the concepts that we have learned here. But I want to just you help me use the chart so that I'm sure we are here. So what are the preprocessing that you have learned or you have been reminded from this short first hour of this tutorial? So you might want to use the comment section to let me know that before we move to another use case. Anybody wants to use the chat to give me a feedback on that? So what are the preprocessing that you've got? Of course, we have several other ones, but I mean, these are like in real life, from my experience too, these are like the ones I've had to use on several projects, that I've had to work on. So I know that understanding how these ones that we've mentioned work, you are more than 50% good to be able to like uh process your data, especially data textual data for tasks like this. Anybody want to say anything, any comment, any question before we move on to another task? Anybody saying anything? Anybody? You can just use the chat. I'm definitely going to pick it up. So I'm just waiting a few minutes. Your comments, your feedback in the first hour before we move to the next phase. Anybody wants to? Thanks. Oh, thank you, Amir, for that comment. Okay, so when we say it is positive, that means that that was a good tweet. So, and of course, it also has to do with the context that you are using it with. But when we say it is positive, we're saying that what this person is saying about our company is good. Or say maybe it's, we're going to look at some real life scenario now, and we'll be able to, talk about things like this. But what we are saying at this point is that when it's positive, oh, it is good. Oh, I like your services. That's what they are saying. That so if many people are saying positive about your company or about that particular task, it means that it is good. If they are saying negative, it means that it is bad. They are saying neutral, that means the person is no longer, the person is not saying anything, whether negative or positive. The person is not saying whether negative. So the person is standing neutral. So for example, if you look at the second tweet, the person says, I am in your DM. So I am in your DM. We cannot completely, say if it's good or bad. We don't know what the person is saying to the company in their DM. So just saying I'm in your DM is definitely, even as women that understand languages, that understand English expression, we know that that person is primarily not doing anything so haunting to the company yet, or anything good about the company yet. But for people who have said something outside, we can leverage on them that way. I hope that explains the tax, what positive means to you, Bola. So any other question or any comments? Okay, so lemmatizing is going to be a picture of the real word is not perfect. So how do we deal with missed spell words? Okay, so let me start from is lemmatizing a way to look for specific word in sentences? Yeah, I mean, if that's the context you understand it, that's what we're trying to do. I'm having a particular word. Can you give me the root word of that word? Of course, before you do lemmatization or stemming, you possibly have tokenized that word. So that means you are having a tokenized pattern of the word. So that word is already in his root word, is in his root word, which is token. Then we are reducing that word, to his root word. A word might not be like I did conferences. Conferences was when I did lemmatization with conferences, it was reduced to conference. So it's more like it's already in its tokenized form, but we want to reduce that word to its root form based on whichever module you are using. So for the word next, these words are being seen and reduce them to their root word. You see, I did finishing. It still saw finishing as finishing. All right, that is the root word that it can really understand. So Rami is saying the real word is not perfect. So how do we deal with misspelled words? All right, so at this point, one of the things that you can do at that point is the question I'm also going to ask is where are you getting your data from? So because for most textual data, we don't really have so much issue with spelling because most time it's automated to get such data. You're not really like the one getting it. But of course, that is why our AI systems are also getting better. Most time what your word wants to do is that it wants to understand the context of each word. So at a point, it's able to like, relate with the word you have and being able to like give something similar to it. So you really don't want to pay more attention to wrongly spelled word, like the context of the word that you are working with. So it all depends on the task you're doing. And of course, you have several words. So you really don't have, your data is huge. You are working with one, a very large data. So you're really not going to pay more attention to wrongly spelled words, at that point. And of course, the algorithm you are doing, the processing that is happening is able to like handle that even for you to some level. But the key word here is that that might not really be something that you want to pay attention to, because you might have, you know, a lot of data, right? You might have a lot of data you are really working with. Okay, so there are several ways of handling data normalization. Of course, we did not really discuss that in this material, as it were. But there are several approaches of, you know, handling normalization, and of course, we cannot even explore all of them now. So, but then one of the things that we can do, especially for the case of S, and that's a tedious, you know, approach, depending on the language you're also working with. You know, it's what helps you to handle that. So, for example, if you want to say a word supposed to be, so for example, C or zeal, you know, if you have seal or zeal, how do we undo, you know, such kind of case? But the question is, which one is really correct? So it's always like from the case that you have, you know, and it's one thing. And of course, your part of speech tagging, you know, is also one precious way that you can actually undo that. Your part of, if you understand the context, for example, if I say seal, if I say zeal, they do not mean the same thing, but they mean different things. So it is the way the word is being seen. And I think that's one of the ways where you might want to talk about word spelling, really. That's one of the ways you might want to talk about word spelling, because in that context of those words, they serve different purposes. And it's a bit difficult to, you know, convert seal to zeal. All right, I hope that's what I'm saying. So, but most time when you understand the POS tagging for such word, can also help you to know how best to handle it, because that's an ambiguous situation whereby unless you as the person using it is able to identify that it's a seal and not a zeal, or it's a zeal and not a seal. So understand that concept. So for handling such case, you have to understand one of the things you can do is your part of speech tagging, because it helps you to understand the context of the usage. All right. And of course, semantic analysis also is something like you might want to try out, which is what we call word embedding, right? It helps you to like identify the kind of words that we can do. But like I said, we really are not able to completely look at all the preprocessings that we can, you know, try out in our NLP tags. I hope that gives some clarity to that use case. All right, so any other question before we move on? Or comment? Okay, great. Thanks, guys, for the question. So we're quickly going to try as much as we can to check out another tutorial. And this time around, we're trying to, so let me check if the screen comes live, okay? Okay, great. So this is a live data that we have on Kaggle. So for many of us who have used Kaggle at one point or the other, or we have an account with Kaggle. So Kaggle is one of the platforms you want to like, you know, get access to data sets. You want to also try, you know, competing with others, and, you know, check out what others has been doing, how they are able to go about it. So for example, you come to your own with the assumption that you have an account already, you'll be able to see some of the tasks that you've done before now. You'll be able to see several competitions, you know, the active ones, the ones that have been done. I mean, you can also look for competition based on your use case. Maybe you want to pick competitions, maybe on, or you want to look for data sets. All right. So the data sets, maybe because you're learning NLP, all right. So you want to look for data sets that focuses on NLP. There are several of them, several use cases, several attempts. And the good part is there are several solutions and patterns that has been used. So for the first task we're going to be checking out here, and of course, I believe that you have access to the materials. We're going to be using the test classification with bag of words. So we want to, at the end of the day, build like a classification task. So here I'm going to connect, you know, what I have here. Okay, and I'll show you something on Kaggle the other time. So I'll come to my account here. and I'll go to my settings, because why am I doing this is because at times you might want to use the data sets directly from your Kaggle instead of having to force download data, because you know that data is on Kaggle, so it's a bit easier. So I'm going to just create a new token. So automatically it's going to download a JSON file for you called Kaggle.json file on your system. So I'm going to be using something like that. So I won't have to go through the stress of downloading my data again. So here, I'm just going to upload my Kaggle, for my download. I'm just going to upload my Kaggle JSON file, which has like a more like authenticating me to be able to use my Kaggle environment. All right. So I have my guys already up, but I've connected to this guy. So let's look at this task now. So maybe I want to check this task out on so this is the data set we're trying to use. So let's look a bit about what the problem is about, and see. Yeah, I want to leave this just that we can understand the problem, because before you can do any task on NLP, any task generated with data, you have to understand the problem you're trying to solve. So Cora, insincere question classification problem. So here what you want us to do is to detect toxic content to improve online conversation. So let's have an overview about the data. Okay, so it says in this competition we have to predict whether a question asked on Quora is sincere or not. So that's like a picture of a classification problem which has a binary classification problem which is sincere or not. All right, so there are several things that I was said here. So time will permit us to start discussing all of that. The data field, we have the Q1, which is the unique question identifier, the question text, which is like the textual data, and of course the last one is the target. Insincere is 1, otherwise it is sincere is 0. So these are some of the things you have to be aware of even as we move on. So if you want to embed some data, these are data you might want to embed. But of course, we're not going to go through all of that at this level. We're just going to do the basic things that are needed. So here we're trying to download data set from our Kaggle to our code lab. So the first thing to do is to pip install our Kaggle, showing that we want to be able to use the Kaggle environment, the Kaggle tools, in this directory. So if you look at what we have here, so I have my Kaggle okay, so yeah, I have this directory. So yeah, you can, if I check the directory here, I have two guys here. The first one is my Kaggle JSON. This is the file I'm trying to work with. And I have my sample data too. So these are like the files that are available here. All right, so that's what I have here, my Kaggle JSON and my file. So everything here is like default because I'm trying to use my Kaggle kernel environment whereby I can fetch my data for me. So the other part here is that I'm just trying to protect my API, from any other person who might want to use this tool, but that means they won't be able to access my API. So even sharing this with you, you won't still be able to do that. You have to like download. That's why I have to show you the approach you can use in downloading your authentication to be able to use this code. So this is a code that Kaggle has already. So we brought this from Kaggle. So if this is able to access the Kaggle, the data directory we want is this. The training data should come from here. The test data should come here. The sample data should come from here. So else, if it's not there, then try to download the zip one yourself. If something went wrong at some point here, let's see. This downloaded successfully. Okay. Okay, so after this are successfully downloaded, I guess it's because I've downloaded it earlier before now. So we can just, import pandas because, it's a pandas data. So I called my data frame raw data pd.read CSV train data. Then I loaded the data here. So I have the Q1 QID, which is like the ID for the questions, the question text and the target. And don't forget the target, when it is 0 means that it is sincere. When it is 1 means that it is insincere. So here I'm trying to check I'm trying to get when the target is 0, which is mean when it is sincere. I'm getting like the top 10 records for that. The first one, these are like the top 10 that we have here. I also did a filtering when the target is 1. That is, this means when it is not sincere. I also got what it looks like top 10 text, question text that we have. Also, I check value count to see normalize true means that it should show the value count in percentage. So for 0, which is sincere, but 93% of my data is sincere. 1, which is not sincere, is about 1% of the data. They are also checked out, a simple bar chart that shows each of these values. For my text data, of course, you know that my text data will not have my target. Just trying to, look at what I have here. QID, which is a picture of the submission. This is just because the task is expected to be submitted as we move on. So I sample my data to have at least just the top 100,000 of the records alone. So now this is where it makes more meaning to what some of the things we've learned before now. So with this, we're going to do some text preprocessing techniques. So we understand bag of words, we tokenize, we're going to do stop word remover, and of course, some bit around stemming. So bag of word intuition. So here we create a list of bag of words across all the text documents. And of course, we're going to convert each of these documents into vector counts of each word. All right, so the limitation is that there are too many words in this data. So, and that's why I was saying at that time that most of the time, in cases like this, you might not even have time to check what the real word is, but you can, just try out preprocessing what you have. So for now, we're just going to check this out on just some few texts. So Q0, which is a sincere word, I'm selecting the result of values that we have at index 1. So do you have a adopted dog? How will you encourage people to adopt and not shop? Q1, question 1 again for not sincere, which is 0. Q1, the result is, as the United States becomes the largest dictatorship in the world. So the first action we are doing here is that we're trying to tokenize. And of course, what is tokenization? Here we're trying to make sure that all of our texts are in word tokenized. So we import NLTK, we import NLTK tokenize, import word tokenize. So we're installing downloading pockets, which is a module that helps us to do word tokenization or do sentence tokenization. Even beyond that, whenever we're using NLTK library. So when we did word tokenize for just that first text, you can see what we have. We're using this smaller one because it's going to take time to process hundreds of thousands of the data, almost 100,000. So that's a lot. So of course, what tokenize on this is something with a lot of punctuation. You can see that the word has been tokenized. Just trying to show a picture of what we have done earlier. Stop word remover on first word, removing stop words on keywords 1. So when we remove stop word, we have as the United States become that is word tokenization. So stop word here also we are storing the values into Q0 underscore token, Q1 underscore token. 0 here means so if you go back here so that you understand what I'm talking about. The 0, we check the data. The 0 means sincere, 1 means insincere. So whenever you're seeing those zeros I'm talking about, that's what we're trying to do here. So we did word tokenize on them and we store them into a variable. So we're removing common stop words. So same thing we imported from nltk.couples, we imported stop words. So nltk.download stop words, that's what we have here. course, again, things we work with, before now. Okay, so that's what we have to this stage. So stemming is happening here. Of course, like I said, if we have go, gone, going, go will be the root word, birds, bird, bird, birds and bed. The root word, all right, is going to be bed. So again, another, stemming module we are using here is snowball stemmer. And of course, we are setting this snowball stemmer to be English. So we're just checking it on simple word. Going gives us go. Stem on supposedly, can you see, give us suppose. This is what I was saying about at times the stemming will give us root word, but they are not vocabularies. Suppose should have an E at least to make a meaningful word. So that's a picture, of what a stemmer we do. And most time we try to use lemmatization than using, stemming. Why? Because for lemmatization gives us a word that is meaningful, all right? That is a word that we can find in vocabularies. And that is what makes it a bit different and a bit unique. Okay, so we've done this, and of course we can see this when we remove the stop word on when it is zero, what is when it is sincere. And of course, when we stem it now, we can see what we have here. Adopt, which is good. Dog, correct. Would, encourage, you can see encourage is having encourage, E is off it. People, E is off it. Adopt again, adopt, sure, you can see. So some words will be meaningful. Some is going to have something that we might not completely be able to interpret, as English, as it were. So same thing is happening here. We have, this is this word that we have removed top word before. Then we stemmed it. You can see united, we have unit. State, we have state. Become, we have become. Largest, dictatorship, word. Okay, so, and of course, we're also talking about lemmatization. Primarily, we also give us a picture of, love, to be love, even when we have loving, love, lovable, when you have several words, it's still going to give you, the root word. So yeah, we want to implement the bag of words. We want to create a vocabulary using Kant vectorizer. We want to also transfer that text to a vector using Kant vectorizer. Then we want to configure the text preprocessing in Kant vectorizer. So now we are working with the entire data. All right. So yeah, in the small data, we're just working with the top 5, and that's what we have here. Then we say from sklearn.feature extraction text import Kant vectorizer. So we make the Kant vectorizer a module. Then we are doing that on the question because it's the text data we are going to work. This is what we are trying to Kant, and of course, before we can do that, we have to first convert it to vectorizer. So what vectorizer does is that it helps us to like Kant because it's going to convert those texts to a vector. All right, it converts those texts to a vector, just like what we did when we're doing TF, IDF. It converts those texts to a vector. So what we have here, and of course, at the end, we have to now use the get feature name out to be able, because at this point, every of the text in our question text has been converted to a space matrix. So we're using the get feature name out to get these guys out. They are not there by default again. And of course, when we fix, we transform finally on the question text. What is question text? Don't forget, the question text is this guy here, where we have our textual data. All right. And it is the one we are trying to process. Like I said, when you fit and transform, you have a space matrix. So you check the shape of the matrix, you have a 5 by 51. That's a 5, rows by 51 columns at the end of the day. So for the question 1 now, all right, the first question, this is what the first question is in our small df.question text. What is the most effective classroom management skill? So when we check the vectorization for this is what we have. And of course, because we intend to also build models as we move on, our models will not understand this text. Our models will understand this vector that we have converted it to. All right, so this is the vector for all the 5 samples that we are working with. So now for the configure Kant vectorizer parameters, we are still using the snow stemmer on it, whereby we can use this, to get some results. So vectorizer equals to, we're assigning the Kant vectorizer, we're asking it to make everything there lowercase to be true. Tokenizer means is to tokenize, that is, tokenize is a method we have used before now. Stop word, yes, English stop words. maximum feature should be 1,000. So it does this on all the sample, data for the question. So vectorizer.fit, we're fitting on all the questions. So we're using count vectorizer to do tokenization, to do stop words, to convert to lowercase. And of course, the maximum features we want to get there is 1,000. You can have as many that you want. So here we can see here that the number of vocabulary we have is 1,000. They want to get all of the words because we cannot get those words again. Why? Because we have vectorized them. So they are more like space matrix now. But to get the word, we can use a method called get feature name out. And of course, that's what we're trying to do at this end. All right. So we also transform, the question text after we have fit it here. Okay, so I'll come back to this. If I have 1 million news stories, each article in a sequential row in CSV, what is the best data structure format to build a sequence to sequence model for text prediction task? So you want to be able to predict, another text. We'll come back to that when I pick up questions. So the next thing we have here is that we can check the number of inputs here, which is going to be, but can you see this? We have about 100,000 records for 100 columns. Because why are we getting the 100 columns? Because of the vectorization that we have done on the task. Then same thing, because at the end of the day, you will still need the text data to be able to check how your task is doing. So we're going to repeat the same thing on our text data. We're going to fit and transform it the same way we have done on our text data. Now, what we intend to achieve at the end also is that we want to be able to predict, on this task. But the key thing to take note is here, you can see the way we have used some of the pre-processing that we learned, before now. And that's like one of the things we're trying to do here. So we are splitting our data. So this is we going back to our normal machine learning task, whereby we can split our data, into train and validation sets. That's what we did here. So, well, take note that our input here is going to be our X data here is going to be our input, not the text data alone. What is the input? The input is our space, our vectorized data. So take note of that. That's the only difference, because we cannot use our sample text like that. We need to have, because we are doing count vectorizer on it. So that's why our input has changed. So our input has changed from our sample question text to input, because we have done vectorization on that. And of course, our Y is our target. Text size is 0.3, which shows that we are trying to test with 30% of the data, while we're training with 70% of the data. And of course, random state 42 shows that we don't want this to change over time. So if we check the shape now, we can see that we have our train input to be 70,000 of the data. The train target is still 70,000. Our validation input is 30,000. The validation target is 30,000. So let's say we want to train logistic regression. So we have to import a logistic regression, which is one of the most easy model that we use whenever we're working with binary regression. That's what we have there. So logistic regression is taking a maximal iteration of 1,000. Solver is SAG. These are parameters that we can also change over time. Okay, so the model was successfully built here over the train input and the train targets. Then we make a prediction here, whereby we have a new value that we have predicted. So we can see from here that our train prediction before was that we have 67,957 that are sincere, 2,043 that are not sincere. Why for our target, our ultra targets, they have 65% that was sincere and 4,000 plus. So you can see at least there's a difference in our results. So when we check through the accuracy score of this model, we have that this is about 95% accurate. Also, when we check the accuracy score, using the length of the target trained target, we have still about 94%. When we check the F1 score, we have about 45%. And of course, the F1 score here shows 0.0. So this shows, of course, it depends on the, the metrics that you're interested in. But with what we have done, it still shows that this model, is still much doing well in respect to the kind of tasks that we're trying to do. So this is a way we can have a textual data, and we can decide to do a text classification, which is one of the way of using your classification problem, text classification problem. Why finally we could just look at the car, we could just look at the car, sentiment that we have. So just like someone mentioned that, how do we know some of these things? So in the car brand, we have the ratings, we have the car year, we have the brand name, we have the date, and we have the reviews. All right. So it depends on which approach are you using. We can directly use the reviews, just like the way we did in the first tutorial. We can use the reviews and possibly use that to generate this, the polarity score. But the approach I used here was just so basic. I just pay attention to the ratings to do that. But you might want to use, the reviews. And of course, what you need to do at that point is what we did here. You're just going to use something like this, to get for the tweets, and you get, the polarity score and all of that here. Of course, for you to use this, I have a CSV file, which is in the material that was shared. You have to also plug this in to be able to use this data set. So the first thing is to import necessary libraries. Here we are doing sentiment analysis. So what I'm trying to do is that I brought like 2 different use cases that we can see how we can build, our own NLP solutions. The first one is that we have tried to do a text classification, while the second one here, we're trying to work with sentiment analysis. So when I loaded the data, I checked the information about the data. I dropped the unnamed 0 because it was an unnecessary column. So I changed the decimal point of my rating because, the rating should just be 5, 4, 2, that kind of picture. So I did that here. So my rating, I can see that there are no missing data. So I plotted my rating per review, so I can see here that I have 5, most of the reviews seems to be good, followed by 4, 3, 2. So most of the ratings are like 5, 0.0. The lower ones are 0. So this is where I decided to create my sentiment to say that any review that is less than 3 should be seen as negative. Any rating that is greater than 3 should be seen as positive, else neutral. Now, why am I doing this is because the rating makes it a bit easier to know what and where each of these review belongs to. Since they've done the rating, I don't need to go through the stress of trying to start from scratch again. I could just leverage on the rating we have. But let's say that there's no rating, then you want to depend on the review to do the polarity score, to understand the negative, to understand the positive, and to understand the neutral. But since they've done this, I'm not sure I need to go through the stress of trying to use the reviews to identify that. So that's why I have this function here, whereby I can use these reviews to segment the result that I have. So if rating is less than 3, I return that as negative. If the rating is greater than 3, that's positive. Else, that is, if it's, say for example, 0 thereabout, it should be seen as neutral. So I decided to create a new data frame, a new column in my data frame called df.sentiment. And of course, from my df rating, which is taking a parameter, dot apply this function on it. So when I take my sentiment, and I can see that most of the review are positive, followed by neutral, and a few ones that are negative. Positive means that they are good review about the cars and their brands. I'm talking about car brands here. Neutral has about 1,954. Negative has about 1,309. So we have the sentiment review analysis. So I just decided to plot it and see that. So you can see more of my distribution based on their reviews. So it's 9.8% is positive, which means it's good. 41% is neutral. 6.1% rather is neutral, and 4.1% is negative. So the positive sentiment is greater than with 89.8%, followed by neutral sentiment with 6.0, and negative with at least 4.0, showing a positive response to most of the cars, right? That's like, one thing you also want to check out. So yeah, I also decided to check what is the length of what people are writing for reviews that are positive. So for people who are writing positive reviews, most of the length of their word is about 470 characters, For people who are in neutral, 645.8 or say, and for people who are writing negative, imagine people who are writing negative are writing more, which is about 801, you know. I mean, these are just things to tell you that people who are making negative review tends to write more from this kind of data set to be working with. And of course, this might be something that you also want to pay attention to. Okay, so one other way to show some of the things that people are saying, you know, in your data is what we call word cloud. So word cloud is a picture that summarizes what people are saying, you know, from your data. So I mean, of course, it might also help you to, as the business owner or the analyst at this point, to understand what people are saying. So the bigger the word, the more the word has appeared, you know, in the data we are working with. So we have more people saying car, drive, love, oh, great, vehicle, good, problem, BW. So, I mean, for anybody who is doing this, you have to also be able to relate to whatever it is you are getting in respect to the business or the domain you're trying to work with. And that's exactly what is happening at this point. So if it is a car, people are saying that they bought the car, it was nice, good, great, they're still driving the car. You know, I mean, several things. The guy is great. They're enjoying the car. It looks better. You know, several things that people are saying. Why you can also decide to filter the, you know, the results. So if it is negative, what are people saying? When it is negative, what are they saying? Of course, this guy is giving them problem. You can see problem showing more. You can see a vehicle. You can see the car. You can see people saying that they are tired. Replacement, maybe there are some part of the car that are not serving them as expected. Replaced, failed. Maybe they didn't like how the car is doing. Failure. You can see some of the things people are saying. Never, that is, they're not possibly going to patronize us again. All right. Performance, you know. So I mean, this is you being able, you have to be able to interpret it in respect to the business. You can see bad here, nothing traded, you know, what people are saying about the car, warranty, liability, we never, you know, you can see the words that people are saying about the car. But people are neutral, what are they saying? Dealer, control, disappointed, highways. You can see what people are saying. So because this also helps you as the business owner or as the company owner to know what and what, you know, to do at every time, at every point, you know, where you are working. So let's see what people are saying. For positive, you can see car, vehicle, love. You can see several things: comfortable, driven model, styling it is nice, overall is good, purchase fast, feature, reliability. Of course, the words might be looking the same way, but because the context we're paying attention to is the sentiment. What are people saying? Right? That's like the point where we use that. Now, so this is the approach of cleaning your data, especially for the reviews. The first thing we are doing is that we are converting everything to lowercase. We are trying to remove every word enclosed in this square bracket. We're trying to remove everyone in this angle. We're trying to remove the hyperlinks or URLs in the word. We're trying to remove if there are certain digits in the word people are writing. Maybe that's a misspell or a typographical error. We're trying to break everything to a new line. We're trying to remove, you know, some digits from the word, some white space from the word. Then we're trying to create a new feature called clean review, whereby you can say it should apply everything that you have written in this function in this clean review, right? So you can now decide to also use this clean review, you know, to work. But what we have here is that using this clean review, now we also created a function called clean stop word, whereby this function is applied on a new feature called review underscore stop word. This is the one that the stop word has been removed. We're applying this method on it. Also, we are using our space. Of course, you know, these are some of the things that we have learned before now, and we are using the English module to be able to, you know, work in the tags. So if you look at what we have here, so we created a function called lemmatization, whereby you want to lemmatize and have every of these words in your review clean. Same thing is happening here. Now that you have cleaned the word, so that means there are some words that might have changed. For example, if you look at what we have here, we are seeing some words that are lemmatized, that are not lemmatized yet, or some words that are still showing stop word, maybe is, you know, all of those English stop words that you might not need. So what we have done at this point is that we have tried, you know, to remove all of those guys. So now we're not still trying to get the results based on the reviews. All right, either it is neutral, it is positive, or it is negative. So what we've done so far is just to show some of the use cases that you can build on based on what we've learned. And of course, understanding some of these things we have discussed in today's class makes you much fit for to be able to explore more in the NLP space. So thank you guys for taking out time to be here. So at this point, we're going to take some questions. Okay, so what is the best data structure to build a sequence to sequence? Well, it really depends on the context of what you're trying to get. But for things like this, I think, I mean, a CSV file should also be good, or you can decide to also have it as a JSON file. It all depends, on the approach you want to use. But whether as a CSV file or whether as a JSON file, you should be good. You should be good. All right, you should be good. So, and of course, even a JSON file makes it more easier because you want to predict, text. So when you say to predict text now, are you talking about text classification, or you want to predict the next text? I didn't get what that part meant. But I mean, having a CSV file or having a JSON file is good for you to be able to work on a data like this. I think you don't have any problem with that. Okay, maxed words. So if it is maxed words, yeah, I think a JSON file is fine to handle that. If it's marked, I think a JSON file is it's a good approach to use to handle such. Yeah, so it's JSON, yeah, exactly, something like that. So one JSON file. Of course, you're still going to definitely have to link all of them together, not article by article. So one JSON file as one article. So it could also be article by article. And you share notebook? Yes, my notebooks have been shared with the team, and they will definitely share with everyone. So I mean, I think it all depends on the approach you want to use. But even if it's a CSV file, even if it's JSON file, you can have all of them. Just make it let it have the JSON format. It can be all of the article in just one JSON file, because also JSON files makes it a bit lighter, to undo and pre-process compared to having a 1 million news story in the CSV file. Yeah. So Rami, the notebooks are available. The team is definitely going to share that with you, or possibly I've shared that with you. You might want to also check your mail to get access to that again. Okay, so if there are other questions or comments from anyone, you could just have that in the chat. I mean, your remarks in respect to the class also, it's a lot for myself and of course, definitely for the team. So thank you everyone for joining the section. All right, thanks guys. So I don't know, the team, you want to say something before we call it? It was useful. Okay, thanks for the comment. Good to hear that. Thank you guys too for joining.
Okay. Hi, everyone. Thank you, Mr. Israel, and thank you, everyone. Again, thank you, Mr. Israel. It was very interesting and insightful. Thank you for everything, and thank you, everyone, for attending the tutorial. We will have a break now, and we will see you back again here at 3:45 p.m. See you.